All right, number 2 here. Once again, we've got our 3 equations. Q is equal to mc delta T. Q is equal to m times L. And then Q lost equals negative Q gained here, right? So what do we have here? This one just says that in the first part, we're melting 50 grams of ice. It doesn't say anything about raising the temperature. It doesn't say anything about that. So if we're just doing a phase change, now you're talking about this equation here. Q is equal to m times L. And remember, for L, there are 2 different main versions of it. Technically, there's 3. L of F is the heat of fusion. And that's what you use for melting or freezing. And then L of V is your heat of vaporization. And that's what you use for boiling or condensing. I doubt they do this to you, but they could give you L of S, which is the heat of sublimation. Nothing says they can't. It's not very common. And sublimation is going from a gas from a solid straight to a gas. So again, that's sublimating. Or the opposite, if you went from a gas directly to a solid, that would be deposition. I doubt they do that to you though. So you're probably going to look mainly at these guys here. Q is equal to m times L. So you just have to decide, are you talking about melting, freezing, boiling, condensing? Because if you're talking about melting or freezing, then you're talking about that. If you're talking about boiling or condensing, then you're talking about that guy there. So all we want to do is, in this problem, we want to know the energy to melt 50 grams of ice. So that's just going to be 50 grams times 333 joules per gram. So the Q for the melting process is going to end up being 16,650 joules, or about 16.7 kilojoules. Now, the second part of it says, what if you were trying to boil 50 grams of water instead? Well, then you'd be talking about the heat of vaporization. So the only difference is that instead of 333, it's going to be 2260. So the Q for the boiling is then going to end up being 113,000 joules, or 113 kilojoules.